Hello students, now I will take the conservation laws of nature. Conservation. Laws of nature. So nature has certain laws which govern the natural phenomena that you have seen in the nature and you see it in your everyday life. So there are three conservation laws of nature. First is conservation of energy. Conservation of energy. It states that energy can neither be created nor destroyed, but it can be converted from one form to another form. The total energy is always conserved. It means that energy can neither be created nor destroyed, but it can be changed or it can be transformed from one form to the another form. The total energy is always conserved. So it means the total energy remains constant. Total energy is equal to constant. This law of conservation of energy always follows in all natural phenomena. There are so many energies in the universe, like solar energy, heat energy, light energy, atomic energy, and that magnetic energy, and the kinetic energy, potential energy, and that electrical energy. There are so many energies. They are always, our universe is full of energy, and these energies are always changing or transforming into another form. You can see around us there are so many cases of this transformation of the energy. Just like we have this, you can see in your houses the electric current, and whatever the appliances are there in your home, they are the means to convert the electrical energy into the another energy. For example, suppose you have a light bulb, then when you switch on, the light energy is converted into the electrical energy is converted into the light energy. So you see it, and when you switch on the fan, the electrical energy converted into the mechanical energy. Similarly, if you switch on the heater, then electrical energy converted into the heat energy. And when you are moving or you are lifting something or pushing or pulling or just moving, then this is what the kinetic energy and the potential energy, that is commonly called the mechanical energy. So there are so many energies in the universe and they always change. They can be converted from one form to the another form. So this is very useful that nowadays the electrical energy is being obtained from in various ways, like from coal, from thermal, this is called the thermal energy, from thermal power, and from the water, then this is the hydroelectric power, and this is converted from this, suppose the nuclear reaction or the nuclear reactor, then this is called the nuclear power. And then we are having this, suppose you are having a windmill, then this is called the wind energy and wind electrical energy. So there are so many forms from where the energy, the electrical energy can be obtained. Similarly, in our life also, when you take the food, then this food is digested in our stomach, that is converted into the energy, and from that energy our muscles are stronger and we act. So we perform so many work in our daily life. So this is what all the machines are made just to convert the energy from one form to the another form. So this energy is always conserved. Whenever this law is violated in some phenomena, it means that it gives birth a new particle that holds this law of conservation of energy. The conservation law of energy is never violated in any physical and chemical phenomena. So this holds good in all these physical phenomena. Suppose you are having, suppose there is a bomb that blasts, then what happens? Inside the bomb there is a chemical material. When this chemical material reacts, then it produces the this kinetic energy and the temperature and that the thermal energy, and because of that when it bursts, then it is the different small particles are moving away from this that of the bomb. So in this case, what we are having, the energy, that the chemical energy inside the bomb, that is converted into the mechanical energy. Because of that, the different particles move in the different directions. So the sum of all these small particles, the sum of energy of the small particles is always equal to the chemical energy of the bomb. So in case the chemical energy is converted into the mechanical energy. So this is what the conversion of energy from one form to another form. Now I am having the second law. Conservation of momentum. Conservation of momentum. Conservation of momentum applies whenever the net force on the system is zero. Then the system is either moving with the uniform velocity or the system is at the rest. In absence of net force on the system, the total momentum of the system is always conserved. It means that summation P, this is equal to constant, or we can write to this, the P is the total momentum of the different particles. So this we take the sum P1 plus P2 plus P3. So this is the vector sum of all this, and this is equal to the constant pair. So this force applies when the net force on the system is zero. This is derived from the Newton's second law of motion. So the particle is not accelerated, but particle is moving with the constant velocity. This law is followed in all physical phenomena. So conservation of the momentum is always valid in all. This law is never violated. Whenever this is violated, there is the production of a new particle. This law is not violated in any physical happenings. So this is always conserved. And now then we are having the third, which is the important law of conservation laws, that is the momentum, this the charge. Here I am telling the phenomena which are in which these laws are followed. And now third is conservation of charge. Conservation of charge. It states the net charge of an isolated system is always conserved, always It means what? That net charge summation Q is equal to constant. So this is follows in all chemical and physical phenomena. It is follows in all chemical and physical phenomena. So this is never violated. In case of chemical reactions, they are always happening. Suppose this oxygen and this hydrogen makes the water. Similarly, this nitrogen and hydrogen makes the ammonia gas. So in all these cases, whenever there is a chemical reaction or the physical reaction, then this law is always followed. So charge is not violated in the case of these phenomena. So total charge of the isolated system is always constant. So isolated system means the system which suppose we are having two or more than two particles which are combining and form a single particle, then this is called the isolated system. So this is not reacting with anything else. So whatever the components that are reacting, that follow this law of conservation of momentum. Thank you very much.